Hello, and welcome to another second grade episode of Math Matters. I'm Mrs. Hale, and today we are going to learn about place value of three-digit numbers. During today's lesson, you will be learning to do the following. I am learning to identify the number that is 10 more and 10 less than a given number up to 999. And I'm learning to read, write, and identify the place and value of each digit in three-digit numbers. You will have a chance to reflect on these learning intentions at the end of the lesson. As you are working today, you will also have an opportunity to practice your communication skills by sharing your ideas through writing and creating mathematical representations. Today you will need paper and a pencil. I will give you some time to gather what you need. All right, come on back and let's get started. A tool that we often use when we work with place value is called base 10 blocks. You may have used them in your classroom. On the left are pictures of the base 10 blocks that I can show on the computer or on the TV. There are a couple of different ways that my 10s and 1s can look. Mathematicians record their thinking and understanding using representations. You can use base 10 representations too, using your paper and pencil. The pictures on the right show what it might look like for you. A hundreds flat might just look like a big square, and you might choose to label 100 either on it or underneath it. You can show a tens rod with a straight line and label it with the number 10. And a 1 square is just one small square that you will use to show 1. Make sure you are careful about the size differences between your hundreds flat and your 1 square. There's no need to get fancy trying to draw the lines like the ones that are on my computer images. Remember, use the simple pictures and show your thinking and understanding as we work today. We are going to play How Many. The number will change by groups of 10. Sometimes we will add 10 or groups of 10, and sometimes we will subtract 10 or groups of 10. Today, our numbers will be three-digit numbers. Use your pencil and paper to write down the end number each time. You can draw hundreds and 10 sticks too, if that helps you. Remember that 100 is a big square and a 10 stick is just a straight line. Let's get started. Our start number is 200, and you can see what 200 looks like. It's two 100s flats. Our change card is add 20. So we're going to add 20. What will be our end number? Use your paper to draw what that might look like and decide what our end number will be. Add 20, and now our end number is 220. How did you do? We're going to try it some more. So now our start number is 220. And we are going to change our number by subtracting 10. What will be our end number? Our end number is 210. Now we start with 210, and we're going to change our number by adding 30. Draw what that might look like and decide where we will end. Add 30, and our end number is 240. Now we are starting with 240, and we're going to change by subtracting 20. So our end number is 220. What part of our number is changing, and what part is staying the same? Why might that be? Think about that as we work with our next group of numbers. We're going to start from a new number, 503. What would that number look like? Draw it on your paper. There's 503. Now, we're going to change that number by adding 10. What is our new number? Our new number is 513. Now, 513 is where we will begin, and we will change by adding 10. Where will we end? Our end number will be 523. Now we start with 523, and we're going to add 10 again. What will be our end number? We end at 533. Are you noticing what is staying the same and what is changing? $533 plus 20 leaves us with an end number of 553. We start with 553 and we add 30. What will be our end number? 583. We start with 583 and we take away 10. What is our end number? 573. Our start number is 573, and we're going to take away 10 again. Where will we end? We will end at 563. We'll start at 563, and we will take away 20. Where will we end? We end at 543. How did you do? Did you figure out what was changing and what was staying the same? You may have noticed that it was only the tens place that was changing. The hundreds and the ones did not change because we were only adding and taking away groups of 10. We're going to take a look at numbers, specifically our 3-digit numbers. Any number has two important parts. They have places and they have value. The place means which space a number occupies. 2-digit numbers have two spaces. They have a tens place and a ones place. We know that it takes 10 ones to make up a 10. 3-digit numbers have 3 places. They have a ones place, a tens place, and a hundreds place. Each place has a value. Value means how much each place is worth. We've learned that it takes 10 ones to make a 10 stick, and that it takes 10 tens to make 100. In the 2-digit number 36, the 3 in the tens place is worth 30, and the 6 in the ones place is worth 6. 30 plus 6 equals 36. When you write an addition problem showing the value of each place, that's called expanded form. What can you tell me about the places of this number? Well, I can tell by the blocks that there's a hundreds place, there are tens, and there are ones. How many hundreds are there? There are 2 hundreds. How many tens are there? There are 4 tens. And how many are in the ones place? There are 5 ones in the ones place. Now let's look at the second part, the idea of value. What is the value of each digit? What addition equation could you write for the number in expanded form? So 2 hundreds are worth 200, 4 tens are worth 40, and 5 ones are worth 5. So our expanded form is 200 plus 40 plus 5. How do you say that 3-digit number? 200 plus 40 plus 5. You say 245. How do you say this number? 716. Take some time to draw this number using base 10 blocks. Your drawing of base 10 blocks should look like this. 7 hundreds blocks, 1 10 stick, and 6 ones. There are 7 hundreds, 1 group of 10, and 6 ones. What is the value of each digit? Write the addition equation for the number in expanded form. So what is the value of 7 hundreds? 7 hundreds are worth 700. 1 10 is worth 10, and 6 ones is worth 6. So our expanded form looks like this: 700 plus 10 plus 6. Here is the expanded form of a number: 400 plus 5. Use the base 10 blocks to show a representation of what this number would look like. It should look like this: 4 hundreds and 5 ones. There are no 10 sticks in the number in the expanded form 405. Now fill in the places to show how many hundreds, how many tens, and how many ones there are. There are 4 hundreds, 0 tens, and 5 ones. How would you say this 3-digit number? You say it as 405. Now let's try using this information to solve some math problems. The grocery store ordered 4 crates of 100 apples, 6 bags of 10 apples, and 3 individual apples. How many apples do they have? Well, we know that there are crates of 100, bags of 10, and individual apples. How many of each are there? There are 4 crates of 100. There are 6 bags of 10, and there are 3 individual apples. How many apples is that altogether? Can you write the expanded form? Try to write the addition equation for this on your paper. It might look like this: 400 plus 60 for 6 bags of 10 plus the 3 individual apples. How do you say that total number of apples? 463. How did you do? We're going to try one more. I can buy stickers in sheets of 100, strips of 10, or single stickers. If I want to buy 489 stickers, how many sheets of 100 should I buy? How many strips of 10? And how many single stickers? So we want to know how many hundreds, how many tens, and how many ones are in our number 489 for 489 stickers. You might want to draw this on your paper. In the number 489, there are 4 hundreds, there are 8 tens, and there are 9 ones. Now, just another side note, there are many other combinations that you could use to buy these stickers. If you use what we learned a few days ago about the number of tens in hundreds, you could come up with some other possibilities too. Maybe you decided there were 3 hundreds and 18 tens because 10 tens make 100. So we just exchanged one of our hundreds for 10 tens to give us 18 tens and 9 ones. There are other possibilities too. I'll show them to you, and then you can play with the idea of exchanging tens and hundreds, or tens and ones. You could also have 2 hundreds, 28 tens, and 9 ones, 100, then 38 tens and 9 ones, or maybe even 0 hundreds, 48 tens, and 9 ones. There are many ways to name a number, and mathematicians learn to be flexible with different ways to create numbers. With practice, this will make more sense to you too. Now let's reflect on your learning. How did you do today working towards our learning goals? Thumbs up, I got it. Thumbs in the middle, I'm still practicing. Or thumbs down, I need some more help. I'm learning to identify the number that is 10 more and 10 less than a given number up to 999. Show me your thumb. And I'm learning to read, write, and identify the place and value of each digit in 3-digit numbers. Show me your thumb. As you think about the learning goals for today, maybe there's something new that you learned that you don't want to forget. Or maybe there's something we talked about today that you still have questions about. Take a minute to record your reflections on today's lesson and save them for the next time you are able to check in with your teacher. In today's episode of Math Matters, we learned about naming the place and value of 3-digit numbers. As you explore 3-digit numbers, keep practicing ways to represent them using your base 10 drawings. I'm Mrs. Hale, and I hope you have a great day and keep on counting.